Welcome to 18th International Conference on Research in Life Sciences and Healthcare 2020. First of all, I would like to convey my sincere gratitude to the organizing committee of Eurasia Research for inviting me as a keynote speaker of this conference. Thank you very much. Role of statistical models to combat COVID-19 pandemic is the title of my speech. I am from Institute of Mathematics and Management, Sri Lanka. First, we'll look at the brief history of global pandemics. The Coco-Leachlie epidemics, which occurred during the 16th century in Mexico. As a result, we lost 13 million human lives. The Black Death bubonic plague originated from China, spread to the Europe and Middle East in 1348. As a result, we lost 25 million human lives in just 5 years' time. Less severe influenza pandemics in 1957 and 1963. As a result, we lost 1 to 2 million human lives. The pandemic influenza virus in 1918 to 1919 spread through America, Europe, Asia and Africa. As a result, we lost 40 million human lives. Today we are suffering with COVID-19, which was originated from China and spread over the world. As a result, we lost nearly 1 million human lives up to now. Now we'll see what is the role of statistical models in pandemic situations. We use statistical models for forecasting purpose. There is no other reason behind. Why we do forecasting? We want to know what will happen in the future. That's why we do forecasting. As humans, we always live with the risk. Risk is part of our life. We cannot avoid risk. So what can we do? We have to minimize the risk. That's why we study that's why we want to know what will happen in the future. That's why we do forecasting with the help of statistical models. On the other hand, statistical models act as a lighthouse. Lighthouse always provides direction to the ship, but not the destination. Statistical models provide predicted outcomes. These predicted outcomes are useful for effective decision making and to develop proactive strategies to minimize the risk. When we talk about the pandemic situations, you can see the outbreaks of pandemics. You can see the patterns of pandemic. Statistical models provide information about the spread of pandemics, about the patterns of pandemic. It will be useful to control the spread in future. And at the same time, these predicted outcomes are useful to take initiatives to combat pandemic situations by selecting effective domestic action mechanisms and also preparing. And this information are useful for allowing for rapid assessment of emerging situations. Now, what is statistics? Statistics is known as mathematics of uncertainty. It plays a vital role in estimation and forecasting of various fields: agriculture, medicine, meteorology, engineering, business, economics, social sciences, etc. Also, it's a vital in the process of mathematical modeling. So what is statistical model? Statistical model is a special type of mathematical model. Statistical model contains all the properties of mathematical model. Hence, it is worth looking at the process of mathematical modeling. This is the process of mathematical modeling. These diagrams explains you the entire process of a mathematical model. Real world problem is observed, identified, and after that a mathematical model is devised. You have to select the mathematical model which is suitable to address the real world problem. Once you select the mathematical model, the model is used to make predictions about the expected behavior of the real world problem and predict. Before you predict, you have to satisfy all validation criteria in the model. If the model is satisfied with the validation criteria, you can gain the predicted outcomes. Once you gain the predicted outcomes, we have to compare the predicted outcomes with observed outcomes with the help of statistical test. If the observed outcomes and predicted outcomes are closer to each other, in other words, the difference is less, the error is less, that model is suitable to forecast, or that model is suitable to address the real world problem. If not, you have to go back and improve the model, or you have to change the track and select another model for this purpose. Now we will see the classifications of mathematical models. Mathematical models can be classified in many ways: static and dynamic, deterministic and stochastic. Now we'll see what is static and dynamic models. Static model doesn't have any time dependent component. If there is no time dependent component, that model we define as static model. In contrast, if a model have time dependent component, we can say that model is dynamic model. Next is deterministic versus stochastic models. Deterministic models are not associated with randomness, or the deterministic model doesn't have any error component. In contrast, stochastic model have randomness or error component. Now this randomness or the error component always associated with a probability distribution, that is called normal distribution. So we referred stochastic models as statistical models. These are the well-known models used by global researchers to address real-world problems. Trend models, growth curve, Malthus, Gompertz, Cobb-Douglas production function, regression model, autoregressive integrated moving average, that is ARIMA, seasonal autoregressive integrated moving average, that is seasonal ARIMA, autoregressive distributed lag model, that is ADLM, exponential smoothing, and decomposition techniques. When we look at the pandemic, COVID, we saw so many research papers published by researchers. Some research papers, they use statistical models for forecasting infected cases and other aspects. Most of the researchers, they use exponential smoothing techniques to forecast. Some people they use ARIMA, some people they use ADLM and trend models as well. But whatever the model, you can select any model, but that model should be suitable to the pattern. Therefore, first you have to study the pattern of the spread. You have to do the pattern recognition. Identify the behavior of the pattern of spread. Then only you can select which model is suitable to the pattern. Here there are a few examples of research papers. These papers focused on modeling COVID pandemic in various countries. In other words, forecasting infected cases, in future infected cases. These research papers very simply explain how to do the pattern recognition, how to study the behavior, how to study the pattern of the spread, and based on that, how to select the suitable model and how to validate the model, what are the validation criteria to be satisfied, and how to verify the model, how to compare the predicted outcomes and observed outcomes in a model-based analysis. It is very clearly explained and it is very simply explained the modeling process. So it is very easy to understand. By reading these research papers, you will be able to learn how to do this process, and it is very simply explained. These papers are available online. You can download it and read. It's very important for you for your future work. This is one example I highlighted. I pick up one research paper that is forecasting COVID-19 spread in Malaysia, Thailand and Singapore. In this paper I pick up only one country, that is Thailand, as an example. The data for daily infected cases during the period, and this data obtained from WHO. This part consists pattern recognition, model selection, validation and verification. My requirement is to explain you the model based analysis in a simple manner. This is the time series plot. Explain the behavior of daily infected cases in the given period in Thailand. This is called pattern recognition. Now you can see there is a pattern. There is a growth, rapid jump of infected cases, and again its decline with heavy fluctuations, and it moves a very lower level. So this time series plot explains the pattern. So this part we have to identify very clearly to proceed further. This is the second part of the data set. This time series plot is for the second part of the data set. Why I said it is second part? Now the first time series plot, I put it to the complete data set from 22nd January to 29th June. When you look at the previous one, you can see there is a rapid growth. Here what I did, I break that, I avoid that growth, and I divided the data set into two pieces. The second part from 25th April to 29th June. Here there is no rapid growth, there is no jump. So this part is more suitable to fit a model. The previous one, there is a jump. If there is a jump, the parameters will mislead. That's why we break this data set into two pieces. This is the second part. This is the second series. the same data series break into two parts, and this is the second part what I am going to use for my modeling. This is the autocorrelation function, and this autocorrelation function we are using to test the relationship between the data within the data set. Here I use this autocorrelation function to test the stationary of the series. That means the behavior of the data set within the constant mean and the constant variance or not. The left of autocorrelation function explain that the data set is non-stationary. Why I said it is non-stationary? You can see two blue color significant spikes cross over the horizontal band. That means the behavior of that complete data set cannot seen within the constant mean and constant variance. That's why we said it is non-stationary. But the second part, when I avoid the jump, I pick the second data set, second part, I break the data set into two parts, the second part from 25th April to 29th June. When I fit the autocorrelation function, when I put the autocorrelation function here, you can see the complete data set, the behavior of the complete data, that data set, the second part, within the constant band and the constant, within the constant mean and the constant variance. Then I can say that part is stationary. Now earlier I did the pattern recognition part. I studied the pattern, identified the behavior of the pattern. Based on that, I selected two models to fit. The first one is autoregressive integrated moving average, that is ARIMA. The second one is DES, that is double exponential smoothing. When we use ARIMA, we have to test the stationary of the series. If the series is stationary, we can use ARIMA. But when I fit ARIMA, that model doesn't work. The next one is double exponential smoothing. There is an exponential growth. We can use double exponential smoothing. Then after the failure of ARIMA, I use double exponential smoothing technique. That model satisfies the entire validation criteria. That is the normality and the independence of residuals. You can see the normality p-value greater than 0.05, and also it confirms the independence of the residuals. That means the errors are not correlated, errors are independent. As I said, in a stochastic model, always the randomness is there, and the randomness is always associated with the probability distribution. That is normality. That is normal distribution. So here the results confirm that. Then at the same time, the model fitting part and the model verification part. The model fitting part, the model fitted. Why I fitted? The model satisfied the model validation criteria. And after that I verified the model. You can see there are two types of measurement of errors: absolute deviation and root mean square error. Both the errors less than 5. It's very low. It's very low. Then this double exponential smoothing model is suitable to capture the number of infected cases in Thailand. In other words, to forecast the number of infected cases, COVID cases in Thailand. Here I further explain the model validation part. Right top you can see the autocorrelation function for errors. Here you can see there is no significant spikes. That means there is no correlation between errors. Errors are independent. So that is one criteria to be satisfied. The other part, the probability plot of residuals, the randomness or the errors are normally distributed. This is the confirmation for that. So I put it for your further information. This is one of the most important part in a model based analysis or in a modeling process. You may remember, as I told you, we have to compare the predicted outcomes and the observed outcomes. This is the stage that we are comparing the predicted outcomes and observed outcomes. This is called model verification stage. Now in this graph, it is very clearly explained the patterns of actual, fits and forecast. It almost follow the similar pattern, quite similar pattern, and it's closer to each other. So based on the predicted outcomes, we can conclude that the number of infected cases would be 0 by 29th November 2020 in Thailand. In other words, you can see by November, after 29th November, you cannot see any infected cases in Thailand. It's a good news, but we don't know what will happen. So this is the predicted outcomes. We get it from the model. Combat COVID-19 pandemic with the help of statistical modeling. As I told you, you can get a predicted outcome from a statistical model. When you observe or when you analyze the predicted outcome, you will be able to understand the outbreak of the pandemic. Based on that, governors, authorities can impose various restrictions to avoid the spread. And also that outcome can be used to assess the effectiveness of containment and various mitigation strategies. To select antiviral strategies, to select the best immunization strategies, these things can be developed by analyzing the predicted outcome from the statistical model. And also authorities can work out the logistic requirement to combat pandemic, and at the same time society can enhance the non-pharmaceutical practices to avoid the spread. Handling a model is a practice. It is like firing a weapon. Before you fire a weapon, you have to do a lot of practices. First you have to study the specifications, then you have to do the practices. The same way, when you get the model, you have to study the specifications first. After that, you can keep on applying to the various data sets. Then you will be perfect of handling model based analysis. Practice always makes perfect. Now I came to the end of my speech. Thank you very much. You can contact me for further information. This is our website. You can contact me for any research work. You are mostly welcome at any time. Remember one thing, this is the high time that we have to share our knowledge and hold our hands together to combat this COVID-19 pandemic. Thank you very much.